Last lesson we have talked about the gravitational force and how it is used to calculate the speed of the planet when we're talking about the planetary motion. So let's have a look. Let's do some revision on the last lesson. So we know that the form of the gravitational force is F equal to GMM over R squared. Remind yourself here is a square. And of course, you should know that the SI unit in the rate R should be meter. And then these two are the masses of the two objects. This is a constant. So we can use this formula to find the gravitational force between two masses. But when we if assume the big M is stationary in the space, and then the small m is rotated around the big M, and then the distance between the two masses, let it to be r, and then we can use the formula of the gravitational force acting on small m would equal to the centripetal force acting on the big M. Oh, sorry, centripetal force acting on the small m. That is mv squared over r or mr over square. It depends on whether you want to find the angular speed or the period, or if you want to find a speed and then you use this one. But if you want to find the angular speed or the period, you use this one. Okay. So let's go on to the next topic. So there's one concept in this topic we need to know about is the gravitational field strength. In last year, we have talked about the electric field, and then we have talked about the electric field strength. If you still remember, when we define the electric field strength is defined as the force per unit charge. So it's quite similar to the gravitational field strength. We use a symbol G. It is the force per unit mass. So if you define it in terms of a sentence, it is defined as a gravitational force per unit mass. So what does it actually mean? So for example, there's a big M, let it to be the Earth. So if you put a very small mass here, okay, and then the distance between the center of the Earth and the mass, let it to be R. So the force acting on the small m, the gravitational force acting on a small m, and then divided by the mass m is the gravitational field strength at this point. So when you're talking about the gravitational field strength, you should specify which point you are talking about. Because if we substitute the formula of the force into the formula, okay, you can see a small n can be cancelled out, and then it gives you a formula for the gravitational field strength. It's gm of r squared. So, and then the r is the distance between the small m and the center of the Earth, and then the big M is the mass of the Earth. So why we need to specify the point? Because the gravitational field strength depends on the distance between the center of the Earth to the object. So let's calculate. So let's have a look at, for example, for the Earth, the mass of the Earth is around 5.98 times 10 to the power 24 kilogram. And then the radius of the Earth is around 6,378 kilometers. So let's find the gravitational field strength on the Earth's surface. So we substitute the formula. The big G is 6.67 times 10 to the power negative 21. Oh, let me use my calculator. 11. Yeah. Times the mass of the Earth, and then divide by the distance square. So 6,378 square. If you put it like this, and you get a wrong answer because this is kilometer, and then you convert it into meter, and then times 1,000. So and then you can try to use your calculator. And then you get a very exciting or very interesting result. So the answer should be 9.81. So that is a number that you should all very familiar with. This is also the gravitation acceleration. So let's have a look at the unit of the gravitational field strength first. So this is the Newton, and then this is the mass. Okay, so you can write it as Newton per kilogram, or because we know that the Newton can be written as kilogram meter per second square by the formula FUMA, and then we can cancel out the kilogram. So it will give you 9.81 meter per second square. Okay, then let's have a look at why this value equal to the gravitational acceleration. So assume the object is free falling on the Earth's surface. So the only force exerted on it is the gravitational force. So if we use the Newton's second law, and it will state that this force equal to ma, and then we know that the acceleration in this case is g 9.81, and then the force is the gravitational force. So we can use the formula, this formula, and then we can cancel out the small m, and you can actually see why 9.81 equal to the gravitational field strength on the Earth's surface. Okay, let's have a try and another question. So let's say the object is very far away from the Earth. So what I mean by far away? Let's say the distance to be is the distance of the object above the Earth's surface is equal to the radius of the Earth. So let's find the gravitational field strength at this point. So the gravitational field strength at this point should, okay, you can substitute in this formula. You are given the mass of the Earth and also the radius of the Earth already. So you can substitute in and you can find the answer. Or you can do it in a more smarter way. You know that the G is inversely proportional to radius square. So when the radius is double, the gravitational field strength should be 1/4 of the initial value. So it should be 1/4 times 9.81. Okay. So these are the concepts that you need to know about the gravitational field strength. So let's draw a diagram for this part. So let this to be F. This is a gravitational gravitational field strength against the distance r from the center of the Earth. So outside on from the Earth surface to infinity, the g is actually inversely proportional to r squared. So the curve should look like this one, inversely proportional to r squared. And then the greatest value is on the Earth surface, that is 9.81. So if the object is inside the Earth, so what does it mean by inside the Earth? So let's say we have construct a tunnel inside the Earth. Okay, so that you can put any object inside at any place inside the Earth, and then the gravitational field strength will be proportional to r, which is r. So I will make another video to talk about this one, but this is not in the syllabus. So or you can just remember this result. So the graph overall, the graph will look like this one, and then that's all you need to know about the gravitational field strength. And then in next video, we will talking about the gravitational potential. So okay, see you.